So, I'm here to talk to you about Newton's laws, in particular, what they are, why they're important, and how they impacted the world. So, Newton's laws, they're written in a series of scientific principles called the Principe. I don't really know how to pronounce it. I believe it's Latin. It founded the basis for discovering the laws of motion in all dimensions, and even furthermore, you could probably say that it founded the basis for all physics. These simple laws that he founded are not only in use in our everyday lives, but will be essential to anyone going into an engineering or mathematical field. You're in use constantly, especially his second law. His theories of motion can be summarized in his three laws, released in each one of his scientific books. First one is an object at rest tends to stay at rest, while an object in motion tends to stay in motion. And this founded the concept of inertia, which means more mass has more inertia. And the idea is inertia is how easily you can move something or cause it to accelerate. So something like my cell phone versus something like a car. A car is more mass, therefore has more inertia, therefore it's much harder for me to start moving in the first place. And if I get it going up to a certain speed, it would take a lot more force to slow it down. Same thing for my phone. I could throw it across the room easily, probably break the screen in half, but I could catch it and stop it really easily as well. Without this idea of inertia, things would act randomly and unpredictable. You'd be able to both push the car and throw my cell phone, and sometimes the cell phone would be harder to throw than the car. That's what this idea acts upon. And then comes the second law, which is there's one big long description, which you can read if you wish, but you can summarize it up in that little equation there in the middle. The net force is equal to mass times acceleration. And this equation is used in all of physics, every single little thing, almost in all of engineering, and it is super important. As a result, this idea of force, there was a unit of force named after Newton. So 1 Newton is equal to 1 kilogram times 1 measurement of acceleration in meters per second squared. So there's mass and there's acceleration, and those two measurements create a Newton. And it's got to be those two in particular. And then comes this third law. For every action, there is an equal and opposite reaction. This creates the idea of action and reaction, right? The idea, okay. So the idea is this. Let's say I hit a nail with a hammer. The hammer hitting the nail would be the action because I'm causing it. The nail hitting back onto the hammer would be the reaction because it's a result of my initial action of hitting the hammer on the nail. Hitting the hammer on the nail. That's exactly what I wanted to say. Hitting the hammer on the nail. Okay? Tongue twister. All right. The idea of opposite is that reaction and action are actually perpendicular to each other, which goes in line with that last equation. And I'll explain why in a minute. And this allows for the idea of normal force, which is in that last equation there, F of n. And it's the opposite force of gravity. Basically, you can kind of think of it as the reaction to gravity, which then can be translated as the reaction to any other action. You just replace that G in, well, it says A, but it should say G, and then you replace it with A. So the idea of perpendicular is that if you're acting upon something with an angle, the angle will then be taken into account with the reaction. And this can be represented in the equation F of n is equal to mass times acceleration times the cosine of theta. Theta meaning the angle at which you applied your force. Alright, that's it for Newton's laws of motion, and I hope you got everything you needed out of the video.